variety of techniques in neuroscience that could be used to inform what's going on in architecture and design. And I'm hoping that this particular study will be an example of how you can use research to inform best practice. Because that's the kind of connection or the sort of subtleties that I see. Oh, thank you. I see you don't want me to. I prefer this setting. Excellent. Okay, thank you. So you can hear me better now? And I can move. I'm not constrained by this. So basically what I'd like to do is to try to give you some ideas about how neuroscience research can inform best practice, because clearly there's a nexus to be mended here. There's some kind of connection that needs to be made, and I hope this serves as a kind of an example. So basically, architecture relies heavily on visual attributes to conceive, design, and control human reactions to the built environment. Now, some current research has investigated the impact of formal aspects of that environment in terms of human perception and cognition, and the idea being that we have, you being architects, me being neuroscience, some sort of seat-of-the-pants notion about what works and what doesn't. And we have some theories, in a sense, that are formal with regard to those kinds of interactions between humans and the built environment. But what's been less studied is the impact of these environmental attributes on the pattern and the nature of how the brain reacts to them. Because it seems to me these will be very useful in terms of insights about what works and what doesn't, what kinds of factors in the built environment might be useful in eliciting the kind of responses that you would like in the context of your clients. So the latter should reveal interesting insights into the how and why in which humans perceive and experience a given built environment, as well as, particularly, the one I'll be talking about today, a simulated healthcare environment. Okay, so this is a kind of a commercial business. So, contours, and we just heard Hannah speak a little bit about it. In fact, I should thank her because she reviewed the Barr and Netta work, which is exactly what this study is built on. Contours represent a fundamental environmental attribute relating to form and is a major consideration when you're designing something and getting clients to like it or not, right? Now, Barr and Netta, as we saw in Hannah's presentation, actually did a study in which they looked at shape preference, right, of everyday objects that were constructed primarily of either angular or curved contours. And as was reported in the Barr and Netta work in 2006, participants prefer objects with a curved contour relative to those that are primarily angular or have pointed features to them. That was a paper that was published in Psychological Science, I believe in 2006. The neuroimaging results in a subsequent paper in Neuropsychologia later on, Barr and Netta reported that not only was there a bias or a preference for these curvilinear as opposed to angular forms, but there was an amygdala activation that was sort of correlated with that preference. Now, what is the amygdala? The amygdala is a kind of emotion barometer that represents threat, okay? So it's part of the system in the brain that has to do with noticing or processing threat potential. And so Barr and Netta, taking their behavioral results and their neuroimaging results, came up with the following conclusion: that sharp-edged objects were less liked and thought to evoke an increased perception of threat as reflected in this correlated amygdala activity. So we're using the amygdala as a barometer of threat, which they believe is responsible for the bias for people liking curvilinear contours as opposed to those that are, should say, angular. Okay, so far? So what's the current study? Well, the current study uses functional magnetic resonance imaging of the brain to try to identify if some of the precognitive responses to these formal attributes of the environment, be they angular or curvilinear, actually manifest themselves in representational states like healthcare settings. Because what we were thinking was that, yes, indeed, people have a bias for angular versus curved contour, but does that bias extend to all circumstances or contexts? And we thought perhaps not. So specifically what we did is we explored brain activation patterns using fMRI to sharp versus curved contours, but they were representing both natural entities like objects and landscapes, but also meaningful built environments like the interiors and exteriors of healthcare settings. So we're focusing down on healthcare settings to examine if angular or curved entities really do exhibit a similar kind of bias as Barr and Nanda found in the context of simple objects. Okay? So the purpose of the study was to determine if that lack of preference for sharp dead objects and the correlated activation of the amygdala as a result of threat could be generalized to this healthcare setting. Because it's not obvious that you can simply go from objects in your world with a bias towards angular contours and apply them to any setting whatsoever. So, what did we do? We had 12 subjects in each of 3 age groups, 20 to 29, 40 to 49, and 60 to 69, balanced for sex for a total of 36. Right? 36 subjects. I can tell you ahead of time, age did not matter. Sex probably does, but it's non-significant given that we only have 12 subjects. In all, there were 48 images that were presented, right? They consisted of objects, landscapes, exteriors, and interiors, and 2 contour types, right? They were either angular, as in sharp, or curved, with 6 instances of each for a total of 48 trials. Now, one of the things that happened was these 48 images were selected from the Herman Miller archive that we had access to and presented in a randomized order, which means any kind of shape could follow any kind of shape. And people were simply asked to imagine they were in a hospital when they viewed this image and to sort of, how shall I say, amplify that characteristic of imagining them being in a hospital. We had beeping sounds and surgical sounds and the kinds of things you hear going on in the context of a hospital or a healthcare setting while they're viewing these objects, while they're in the fMRI scanner. Okay? So the images were presented for a very brief period of time, only 150 milliseconds of exposure. Barr and Nanda used only 85. So we were well within the range of individuals perceiving the images or the entities. And then the subjects had an additional 1,850 milliseconds to sort of rate, do you like this image or do you not? Okay? So what do we find? Oh, before we do that, here are examples of the entities in each of the categories. So here you have a sharp object, a sharp interior, a sharp exterior, a sharp landscape, a curved object, a curved interior, a curved exterior, looks kind of like a beehive to me, and a curved landscape. So those are the kinds of entities that you can imagine yourself seeing in the context of a brain scanner while you're lying on your back looking at these things, listening to hospital sounds, and trying to rate if I like these images or not. Okay, 7-point scale. Neuroscientists in the audience, right? Here are the fMRI parameters, which, by the way, is not a trivial matter. So when we were talking about all those techniques that could be used in the earlier session, there's a whole lot of learning curve associated with using things like fMRI or EEG or near-infrared. Okay? And so for those of you who are of interest, here are the actual fMRI parameters that were utilized at the Texas Tech Neuroimaging Institute. Okay, so we do the study, what do we find? We find basically after the entire 2 seconds is gone and individuals have rated, do I like the image or not, we basically find the exact same results that Barr and Nanda do. That is, after 2 seconds of exposure time and an evaluative judgment, individuals actually prefer curved to sharp objects. This is basically, right, the Barr and Nanda result, but it's been extended now to interior, exteriors, and landscapes. But there's an interesting neural phenomenon that precedes this, and that is where the neuropsychology paper of Barr and Nanda revealed that amygdala activation was significantly greater in the angular than the curved for objects. We find that. When curved and angular entities are associated with a landscape, we find that. But when interior and exterior of hospital settings were involved, we got a reversal. right? That is, the amygdala was more active for curved rather than sharp entities. This is a sort of surprising result unless you take into account the importance of wayfinding and directional accuracy. Here are just pictures of more activation for sharp for curved for objects, landscape, sharp for curved, exterior. This is just amygdala, by the way, region of interest analysis. Okay? So what do we conclude from this? The behavioral results look just like bar and netta after a 2-second evaluative judgment. But what happens is there's a reversal in the amygdala activation, which is a barometer of threat or potential anxiety. And so what happens in the healthcare context, right, is that finding one's way, like to the laboratory or back to my room, you need certain directionality. You need to have unambiguous directionality or wayfinding information because it has such high utility value. And if you don't provide that, there's an initial anxiety about this particular built environment. Notice it goes away within 2 seconds, basically saying, I was anxious about it, I'm not sure I could find my way, but I finally did and it's okay. But there's an initial stage of processing in the brain which says anxiety provoking because of the ambiguity of the directional information in a healthcare setting. Now, what does future research need to do? We need to find if other utility-laden environments like railway stations or airports are going to evoke that same kind of meandering anxiety that's associated with potentially a healthcare setting. We also need to find out if there's differential activation in the right and left amygdala because they actually show different kind of response to different kinds of threat. And in this instance, we're considering wayfinding as the primary threat and accuracy of information in finding one's way being an important context or characteristic of a built environment that has utility for those kinds of service-oriented needs. Aesthetically pleasing objects, aesthetically pleasing meandering in a landscape. I don't like to meander around the hospital when I'm finding my way. And with that, I'd just like to thank my collaborators, one of who is here, Upali is here. But hopefully this is an example how you can use brain research, functional magnetic resonance imaging, to kind of reflect on or inform best practice when it comes to designing a built environment. Thank you.